All right. Well, in an effort to get this done early, you guys have just finished geometry test 1 through 55. So obviously the next thing that you guys need is you need to be getting ready for test 1 through 60. So I'm going to go ahead and get started with our review here. Try to give you all the information that you're going to need so you guys can get hopefully an early start and actually look at some of this stuff. All right. Let's see, Geometry Review 1 through 60, question 1 comes from lesson 52, properties of rectangles, rhombuses, and squares. So our question here is, if a parallelogram LMNO is a rhombus and not a square, which of the following is true? So we're looking for something that is a rhombus but not a square. So if we're going to draw it, let's not draw it as a square. We do know something about a rhombus. We know that all four sides are congruent, and if we draw this, we draw LMNO. Okay, now let's look at some information here. It says measure angle O is 90 degrees. Well, if measure angle O was 90 degrees, it would force all my other angles to be 90 degrees. My rhombus would end up becoming a square because it would make it a rectangle. A rhombus that is a rectangle is a square, so that won't work. We want it to not be a square. It says that LN is perpendicular to MO. All right, LN is perpendicular to MO. All right, well, those are diagonal lines, and in a rhombus, the diagonals are perpendicular. It does not have to be a square. Now, if we could look at the rest of these, angle L being congruent to angle M, again, would force that to be 90 degrees, which again would make it a rectangle, which would again make it a square. We also have LN being congruent to MO. Well, in a rectangle, diagonals are congruent. So again, we don't want to make our rhombus a rectangle because that would make it a square. Okay, so that's why we wind up with B as our answer here, that we just want our diagonals to be perpendicular because it's the one way that they give us that we could have a rhombus that is not forced into a rectangle and therefore is not a square. Okay. Question number 2, we've got a proof. You can look at lesson 60 proportionality theorems. It says complete the following proof of the triangle proportionality theorem. Okay, so we are given that DF is parallel to BC. We want to prove that AD over DB is equal to AF over FC. So let's go down here and let's look at the other information that they give us. Let's see, DF is parallel to BC, that's my given. Angle ADF is congruent to angle B. So what they're saying is angle ADF is congruent to angle B because they're corresponding angles. Okay, I've got two parallel lines cut by a transversal. Okay, making these two angles congruent. So if I've got my two parallel lines here and here, then my red line is my transversal. So those angles are corresponding. Angle A congruent to angle A. Okay, so let's look at that's there and there. So we've got our large triangle here that shares angle A with our smaller triangle here. Okay, if we go down here, and I know that's going to move my picture around a little bit, but we should see 4 options. And we should see the reflexive property of congruence. We're going to call that normally the reflexive axiom, but here we'll use the reflexive property of congruence. So anyway, with that should narrow us down to 2. And then we have triangle ADF is similar to triangle ABC. Okay. And what we want to see there is because notice that we have 2 angles. We've got this angle here and this angle here with this angle here and that angle there, which means that I have an angle-angle similarity postulate. Okay, so we can look at angle-angle similarity along with reflexive property. You'll notice that that's only going to leave you with one answer left, which is B. And then we should see down towards the bottom here, let's clear this out, as they follow this on down through. On number 3, you look at step number 7, they're going to subtract 1 from 1. So they're going to subtract, minus 1, minus 1. It's going to cancel my 1's out. And I'm going to use the subtraction property of equality on number 3. So B would end up being my answer. The biggest part of this that you need to be able to determine, though, is this right here. Okay, reflexive axiom and angle-angle similarity. Okay. All right, number 3, ratios, proportions of similarity. Here we're going to notice that it's triangle ABC to DEF. Okay, so we're going to compare, if we look at AC, it says AC, well that should be to DF, so that's this side to this side. Okay, we want to find X, so let's do X over 4. And the other thing that they show me is, and I could set this up a number of different ways, but notice that they show me AB to DE. Well, that would be 6. Oh, sorry. That would be DE 12 to AB 6. So cross multiply and divide. 4 times 12 is 48 times 6x divided by 6. Okay, on number 3, 48 divided by 6, 8 equals x. And they just wanted you to solve for x, so we're done there. So always make sure that you're answering the question that is being asked. Okay, number 4, find the length of x in the diagram. Number 4 comes from lesson 43, chord, secants, and tangents. Find the length of x. Well, this comes from needing to know that if I have a diameter that meets a chord at 90 degrees, then it will bisect that chord into 2 equal segments. So x equals 6. So with that, you need an explanation. You need to be able to say a diameter that meets a chord at 90 degrees bisects that chord. Okay, you can go and you can look at the specific theorem or postulate in lesson 43. Okay, number 5. Okay. Number 5 comes from lesson 44, applying similarity. Landscape architect is designing a garden in the shape of a regular pentagon. Regular tells me 2 things. It tells me all the sides of that pentagon are going to be the same length and all the interior angles are going to be congruent to each other. The side length of the garden measures 3 inches on a blueprint, with the scale being 1 to 5. I actually don't even have to draw this. We got 1 to 5, 1 inch to 5 feet. Okay, how many feet of fencing will be needed to surround the garden? Okay, so if we have the side length of the garden is 3 inches on the blueprint, okay, then what we're going to solve for is how many feet that side is going to be. All right, so we have 5 times 3 divided by 1, and actually we're going to end up getting 15 feet. X equals 15 feet, but we're not done yet because that's just one side. Okay, one side measures 15 feet. Each side measures is the same length. So we're going to take 15 times 5. We're going to get 75 feet of fencing. Okay, again, answer the question that's being asked. Now, you could have done this a little bit differently if you wanted to. Because they're only giving me side length and ultimately what I'm looking for is perimeter, I could have taken 3 and multiplied it by 5 right off the beginning and gotten 15 inches, and taken 5 times 15 divided by 1, I still would have gotten x equals 75 feet. And you don't have to convert. Your inches will cancel out and you'll be left with feet there. Okay. All right, number 6. Number 6 comes from lesson 51, properties of isosceles and equilateral triangles. And a triangle is equiangular. Okay, hopefully we remember that all equiangular triangles are also equilateral. It has a perimeter of 27. Perimeter means that all sides add up to 27 inches in this case. Determine the length of each side in inches. Well, if it's equiangular, then it's equilateral, which means I'm going to take 27 divided by the 3 sides of that triangle, and I'm going to get 9 inches is the length of each side. Okay, that's my work there. Okay, let's come up to number 7. Number 7, lesson 52, properties of rectangles, rhombuses, and squares. A rectangular frame, okay, a rectangular, that's going to be my important word there, is divided by diagonal edges as shown below. If PI, okay, let's go ahead and draw a line there. PI is 6 inches long. What is the length of QR in inches? Well, what you need to know here is that in a rectangle, the diagonals are congruent. The other thing that you need to know is that a rectangle is a parallelogram, and in a parallelogram, diagonals bisect. So, if I know that in a parallelogram diagonals bisect, then I know that IS is also 6 inches, and 6 plus 6 is 12. Therefore, QR, because in a rectangle, diagonals are congruent, QR equals 12 inches. Okay? But you want to state those facts. Okay? I want to know that you know that a rectangle is a parallelogram and what rules for the diagonals of a parallelogram work and what rules for the diagonals of a rectangle work. Okay, number 8, lesson 52 as well. Rectangular bookcase shown below has braces diagonally across the back. Determine the length in feet of the brace that will be used for diagonal WY. Okay, this one actually uses the Pythagorean theorem to solve it, because what I'm forming here is a right triangle where WY is the hypotenuse opposite the right angle X. Because it is a rectangle, the angles of a rectangle are right angles. So we've got 10 feet. Okay, 10 squared plus 24 squared equals C squared. So we have 100 plus, let's find out what 24 squared is. 576. Okay, so we've got 676. And we want to square root both of those. Square root of 676 is 26. 26 equals C, and that is in feet. 26 feet. All right, that was number 8. Okay, let's clear that up and let's go on to question number 9. Question number 9, find the perimeter in inches of the triangle to the nearest 100th foot. This is lesson 53, 45, 45, 90 triangles. Notice that I have a right angle and a 45-degree angle. And we know that we only have 180 degrees in a triangle, so 90 and 45 is 135. Subtract that from 180. Okay, in a 45-45 right triangle, the sides opposite my 45s, because my angles here are congruent, are going to be the same length. So I know that this is 4 inches as well. And the ratio is x to x radical 2. In this case, x equals 4. So my hypotenuse is 4 radical 2. Okay, so if we want to find the perimeter in inches of the triangle to the nearest 100th foot, we're going to take 4 plus 4 plus 4 radical 2, or 8 plus 4 radical 2. 8 plus 4 radical 2. Okay, and I'll show you on the calculator. Oh, wrong thing. There we go. 8 plus, out of the way, 4 radical 2. Okay, we should get 13 if we need it to the nearest hundredth. 13.6. I would make that 13.66. Let's see what their answer is. Yep, 13.66 is my answer. Okay, 4 plus 4 plus 4 radical 2 is 13.66, and that's the work that I want to show. Okay, number 10. Number 10 is lesson 59, surface area and volumes of prisms. Find the volume in cubic feet of a right prism where the base is 10 feet by 5 feet, rectangle, and the height is 3. So in a rectangular prism, or in any prism, you need a couple of things. In order to find the volume, you need the area of the base polygon, or capital B, times the height. In this case, what they're showing me is that my base is 10 feet by 5 feet. Okay, and because it's a rectangle, I can find that area pretty easy by length times width, which in this case is going to be 50 feet. Okay, 5 times 10 is 50. And we have a height of 3. So we're going to take that 50 times 3. 50 times 3 equals 150 feet cubed, because that 50 feet here is squared, and this feet here is to the first. So we're going to add those exponents up. We get 150 feet cubed. All right, we'll move on. Okay, number 11. Number 11 comes from lesson 60, the proportionality theorem. All right, and in our proportionality theorem, what they show me is that if I have parallel lines that cross transversals, and they split it into congruent segments, like I'm seeing here, 6 and 6. Then on the other side, they are equal to each other as well. So 2x plus 1 will be equal to x plus 5. Now you could also solve this as a proportion where you're doing, say, 2x plus 1 over this 6 here is equal to x plus 5 over this 6 here, or even more directly, we would see, 2x plus 1 over x plus 5, and this be equal to 6 over 6, which is equal to 1. But in the end, because those 6's are the same, 2x plus 1 can be said to be equal to x plus 5. So we just simply solve for x, subtract x there. That's just going to leave me with x. Subtract 1, x equals 4. And it says final length of AC. And that's the really important part here, because it doesn't want just what is x. So we actually want to take and substitute 4 in for x. But because these are the same, because CE is equal to AC, you can plug 4 into my x here instead of my x here and save yourself a step, because 4 plus 5 is 9. That's a lot easier answer to get, although 2 times 4 is 8 plus 1 is 9. It's not a much harder answer to get. And that's lesson 60 proportionality theorem. Okay, number 12. We've seen this question on our last review. Okay, if we've got, our sunshine in here, and we've got our tree here, and we have our little kangaroo whatever there, and we've got these shadows coming across, okay, and we should end up with these similar triangles. Okay, on a sunny day, 3-foot kangaroo casts a 4-foot shadow on a nearby eucalyptus tree, which a shadow here is 12 feet long. We want to find out the height of the tree. Okay, they're basically just wanting you to set up a proportion first, so you could do, tree height over kangaroo height is equal to tree shadow over K shadow. Okay, something like that. In the end, we want to be able to solve. So if we're going to use that, we're going to use, tree height, we put H there, over kangaroo height, 3, is equal to tree shadow, 12, over kangaroo shadow, 4. We're going to take 3 times 12, which is 36. 36 divided by 4 is going to be 9 feet. So the height of the tree is 9 feet. Okay, so they're going to ask you to set up a proportion based upon the comparison of the tree to the kangaroo and the comparison of the shadow of the tree to the shadow of the kangaroo, and make sure that you set that up right. There's 3 or 4 different ways to set it up. Make sure that it's the right way, and then ultimately you're looking for the right answer in terms of the tree height. All right, number 12 was out of lesson 41. Number 13 here is out of lesson 43, chord secants and tangents. Again, it wants you to find BD. I think we've seen this question before. That's fine. But we want to find this line. The important thing to remember is that I can draw any number of radiuses. So let's say I can draw that line to right there, and that's going to end up completing a right triangle. Okay, and because AF is 10, A to C is 6, and C to F is 4, that tells me that the radius of the circle is 10. So I know that any radius of this circle is going to be 10. Okay, so I can find BC, and the reason I'm finding BC is because I know that this radius bisects BD because it meets it at a right angle, and that's one of my rules. So if I can find BC, then I can double the length of BC to find BD. So a couple different things. Well, one, we can do x squared plus 6 squared equals 10 squared. We've got x squared plus 36 equals 100. Subtract 36, x squared should equal 64 square root both sides. We get x equals 8. A lot of people stop there. We don't want to stop there. We want to take 2 times 8 and get 16. BD equals 16. I think you saw this question on your test 1 through 50. Okay, a lot of folks got it wrong then, so hopefully if you see this again, you won't get it wrong on your next test. Okay, 14. Let's see, 14 comes out of lesson 44, applying similarity. So a lot of similarity questions. Community. The plans for a new community include a rectangular park, has a perimeter of 720 feet. Dion creates a model so that the similarity ratio of the model to the park is 1 to 400. What is the perimeter of the model in inches? All right, what you have to remember, about this is that scale factor is proportional to the ratio of the perimeters. So if I've got 1 over 400, I want to make sure that I put my 720 feet for my park down here and solve for inches up there. So really it's 1 times 720, which is 720. 720 divided by 400. Okay, move this over, clear that out. 720 divided by 400. Okay, it looks like, to me, like 1.8 inches. Let's see, we're on 14. It comes out as 1.8, but it's actually in feet. So what we need to do is we need to multiply those feet by 12 so that we're getting inches. Okay, so 1.8 times 12 is 21.6 inches. Okay, that is my answer. Okay, because they don't tell you, but this 1 to 400 is in feet. Okay, it's 1 foot to 400 feet. So we need to convert that. Okay, let's move on to number 15. Come back up here. Okay, find the angle measure of ACDB. Find the angle measures of ACDB. Okay, let's see. Lesson 15 is circles and inscribed angles. Okay, circles and inscribed angles. This comes from lesson 47, circles and inscribed angles. And this is one I actually had to go back and look at because I don't memorize everything, but there's a really important theorem, which is theorem 47-4, which says if a quadrilateral is inscribed in a circle, then it has supplementary opposite angles. So that's important here. Supplementary opposite angles. Because a trapezoid is a quadrilateral, A and D are opposite angles and they're supplementary. So what I can do is I can say 2x plus 3 plus 3x plus 7 is equal to 180 degrees because supplementary angles add up to 180. Then I can combine like terms. So I've got 5x plus 10 equals 180. Subtract 10. Okay, so I got 5x equals 170. Divide by 5. And this is just solving for x. It's not getting me my answer, but it's going to get me a lot closer to it. So we're going to take 170 divided by 5. We're going to get x equals 34. Okay? And once I have that, now I can throw that back in. So if I want to, and I'm going to keep my x equals 34, I'm going to erase the rest of this so I have some more room to work. Okay? So we want 2 times 34, okay, plus 3, because that's going to be angle A. Okay, well 2 times 34 is 68. 68 plus 3 is 71 degrees. Okay, so I know angle A is 71 degrees. Now keep in mind that the same rule still applies. Opposite angles are supplementary. So I don't have to plug 34 into 3x plus 7. I could subtract 71 from 180 and find out that angle D is, let's say, 109 degrees, I believe it is. Yeah, angle D is 109 degrees. Okay. I will plug my 34 in for angle C, 4 times 34. Okay, 4 times 34, 136 minus 10, minus 10 is 126, so angle C is 126 degrees. And that's actually how I'm going to end up finding angle B, is subtracting 126 from 180, so angle B, okay, should be 54 degrees, if I got that right, 54 degrees. Okay, and you're going to want to show all of your work for that. I know I've done some of it in my head. You want to show me that you know exactly what you're doing. Okay. All right, 16. 16, classify the figure, name the vertices, edges, and the base. Okay. So this is going to be one of those answers where the answer is to your work. It says classify the figure. We're going to classify this as a rectangular pyramid. If you're going to see probably on your list of possible answers, square pyramid, I don't have enough information to say that this is a square pyramid because I don't know that DF, FB, BC, and DC are congruent. I don't know that they're the same lengths, but we've got enough to probably say that it's a rectangular pyramid. If you wanted to say it's a square pyramid and let's say it wasn't a multiple choice question, I might let you off the hook on that. Your vertices are your points. So point A, point F, point D, point B, point C. Those are your vertices. And then you have your edges. So your edges are, we want to see them this way. So my edges are AD, AC, AB, AF. Right, there should be several of these. So, DF is an edge, FB is an edge, BC is an edge, and DC is an edge. So there should be 1, 2, 3, 4, 5, 6. There should be 8 edges with base. My base is rectangle. Okay. FBCD or BCDF probably. BC or whatever. Yeah, BCDF is what we're going to call it. Okay. All right. And again, classifying a figure, you would write rectangular pyramid. Okay. Number 17. Number 17. 17 comes from lesson 52, properties of rectangles, rhombuses, and squares. Diagonals of a rectangle ABCD intersect. All right, so let's draw a rectangle. Okay, we know we have right angles. Let's call it A, B, C, D. We have to go in order around. We're going to make some diagonals. Okay, and we're intersecting at point E. Okay, if AE is 4 inches long, what is BD? All right, well, we've come across this before. So we know the EC is 4 inches long because a rectangle is a parallelogram and the diagonals of a parallelogram bisect each other. And because it is a rectangle, the diagonals are congruent. So 4 plus 4 is 8, therefore DB is 8 inches long. Okay, but you need to know, and again, you need to state. Okay. Okay, let's come down to number 18. Okay, it says figure STUV is a parallelogram. What is the value of X? Same principle again. Because it's a parallelogram, the diagonals bisect, which means these are going to be the same length. So 2x minus 3 is equal to 3/2 x plus 3/4. Now, my recommendation to this is to multiply all of this, okay, so that I get rid of these fractions. Okay, and so what I would do is I would multiply by my largest denominator there, which is 4. Okay, so I'm multiplying by 4 all the way across. So I'm getting 8x minus 12. 4 times 3 is 12. 12 divided by 2 is going to give me 6x. 4 times 3, again, is 12. 12 divided by 4 is 3. So I'm getting something where it's all kind of straight across. It's going to make it a lot easier to work with. So subtract 6x. Okay, so I'm getting 2x. I'm going to add 12. I'm getting 2x equals, looks like 15 divided by 2. X equals 7.5. They just wanted me to solve for x. So x equals 7.5. Okay. All right. 19. Okay. 19 comes from lesson 51, properties of isosceles and equilateral triangles. Get moved over here. It says find CA. What you need to notice first is that all of these angles are congruent, which means all of these sides are congruent. So s plus 2 equals 2s minus 10. The first thing we're going to do is solve for s, but that's not where we're going to end because they said find CA. A lot of people miss this question because of that. So let's add 10. Let's subtract s. It's going to leave me with just one s. S equals 12, but they wanted me to find CA. Okay? So in order to find CA, I actually need to know what one of the whole sides equals. Okay? Well, 12 plus 2 is 14. 2 times 12 is 24. 24 minus 10 is 14. Therefore, CA is 14. Okay, not 12. 14. Okay, number 20. Number 20. Okay, find the value of x, express your answer in simplified radical form. What I'm seeing here is that these two sides are congruent, and it is a right triangle, which makes it a 45 right triangle. So I've got x, which means 5 equals x radical 2. If I want to solve for x, okay, we're going to divide by radical 2. Okay? So 5 divided by radical 2 needs to be simplified, so we're going to multiply by and rationalize the denominator by multiplying by my denominator over my denominator, giving me 5 radical 2 over 2, which does not reduce. That's question number 20 coming from lesson 53. Okay, let's scroll back up and grab question number 21. Okay. You've seen this question on your last test recently. You saw it on the review before that. You're taking 16 plus your 0.5 and your 0.5, and you're getting your 17. Okay, because this whole length is 17. Because this is a 45, 45, 90 right triangle, we're getting L radical 2. So 17 equals L radical 2. We're going to divide by radical 2 to solve for L. And because they want our answer to the nearest meter, we're simply going to plug this in our graphing calculator. We're going to show 17 divided by square root of 2, and how that equals 12 meters. Okay, a lot of people still getting this question wrong, which is why we continue to see it and work it out. All right, number 22 comes from lesson 55, triangle mid-segment theorem. All right, it says given that triangle ABC, it tells me that AB is 3. Basically gives me all the information I see in the picture. Okay, AC is 6. We want to find the length of mid-segment XY. Because they tell me it's a mid-segment, the mid-segment is always 1/2. the side that it is opposite of. It's opposite of 3. So 3 divided by 2 equals 1.5. Okay. Let's see if that's an acceptable answer on that. And it is. XY equals 1.5. Okay, 23 gives me a 30, 60, 90 triangle. Okay, 30, 60, 90 triangle works on an x, 2x, x radical 3 ratio. Okay, so the first thing I'm going to do is solve for x, right? If 24 is equal to 2x, we're going to divide by 2 to solve for x. Okay, 24 divided by 2 is 12, so I know x is 12. And then if x radical 3 equals 12, okay, x radical 3 equals 12, okay, you could divide by essentially you're taking x times radical 3. So really we're just left with 12, and this equals 12 radical 3. Okay, because x equals 12. So 12 and 12 radical 3 are your x and your y because of your ratios. All right, gets me to 24. Yield sign. Okay, this is going to work like this. So 30, 60, 90. Well, really, they tell me that okay, then I've got something like this, where, let's see, my length of my metal is 36 by 32. I need to know, because this is 36, so I know that my metal is wide enough. I need to know if it's, or I know that it's long enough. I need to know if it's wide enough. In order to figure that out, I need to actually know the height of this. Because it is an equilateral triangle, it also means it's equiangular. And because this is an altitude here, it means that it's going to divide that angle into two congruent angles, and it's going to meet this perpendicularly as well as bisect this line right here. So that 36 is going to get divided into 2, so I know that that's going to be 18. I know that this is still 36. I know that in an equiangular triangle, all normal angles are 60 degrees. And like I said, we bisected this one, so this is a 30, 60, 90 triangle. So you got a couple of different things you could do here. You could do x squared plus, plus 18 squared equals 36 squared and solve for x, and that would certainly do it. But in a 30, 60, 90 triangle, like what we saw in question number 23, it goes x, 2x, x radical 3. So I know what I'm working with is that my height is, 18 radical 3. Okay, and so I can find out what that length is going to be by taking 18 times radical 3. Okay, I'm getting 31. 31, I believe, inches. And if this is 32 inches, and this is 31 inches, I know that this is going to be long enough. So my answer is going to be yes. The height of this is only 31 inches, okay, which is less than 32. But I have to show my work, okay, whether I'm using the Pythagorean theorem or my ratios. I have to show my work. Okay, 25, finding perimeter and area with coordinates. This says estimate the area of the irregular figure. Each square represents 1 unit. What I typically do with these is it's an estimate. So, you take your whole blocks, or your ones that are close to being whole blocks. And some of these you can kind of estimate together, ones that make up other ones, stuff like that. We know we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is pretty much going to make one whole block. 14. We've got probably a whole block here. 15. Probably a whole block here between there and there. 16. Probably a whole block there. 17. Maybe about an 18. 19. And we've got between here and here 20. So I would say about 20, and I think the answer in this is 23. We could probably get 21. And there might be enough around there to get 2 more out of it. Like I said, it's an estimate, so they're going to be giving you ones. If you saw this question on a test, things that are close enough that you should be able to pick it out. Okay. Like I said, it's an estimate. There shouldn't be 2 answers that are super close together to being right. 26. 26 comes from lesson 58, tangents of circles. And what they tell you in that lesson there in 58 is if I have 2 tangent lines that are drawn back to the same point, that those segments are congruent. So 3y plus 4 equals 11y. It says find AB. So the first thing we're going to do is we're going to solve for y, and then we're going to plug y back in. So we can subtract 3y. We're going to get 4 equals 8y. A lot of people divide by 4. We don't want to. We want to divide by 8. So y equals 1/2. And then it says find AB. So you can plug 1/2 in there, or you could plug 1/2 in here. They're going to be the same. So AC, it's 11 times 1/2, which is 11 halves, which is the same thing we would get for AB. And 11 halves is my answer. And it's a lot easier to plug it into AC than AB. All right, 27. Hopefully I can get through most of these. Determine the amount of wrapping paper needed for a rectangular box. Okay, so we're looking for surface area. Ryan finds the surface area of the box. How much wrapping paper is needed if the box measures 12 by 2 by 4? Okay, looking at something like that. We could say 12 by 2 by 4. If you want surface area is found by taking the perimeter of the base, okay, times the height. Okay, well, that's going to give you your lateral area, and then we're going to add the 2 bases on top. So your formula is surface area equals your perimeter times your height plus your area or plus 2 times your area of your base polygons. So your perimeter around this is 12 and this is 2. So you've got 24 plus 4, which is 28 times 4 plus 2 times the area of your base. Your base is a rectangle, so 12 times 2 is 24. So that's your math there. So let's go ahead and calculate that. 28 times 4 plus 2 times 24. And I get 160 inches squared. 160 inches squared of wrapping paper. There's a number of different ways to do that, but I'd like you to know your formula. Okay, 28, verify that NQ is parallel to PR. If NQ is parallel to PR, then these transversals are going to be divided up proportionally. So 16 over 8 is going to be proportional to 12 over 6. And 16 over 8, you notice that rule will reduce to 2 over 1. So will this. So we know that those are parallel.
Your then announcement is 30
All right, so the actual listed answer here is NP over PM, and you can do that as well. You know, NP over PM, so 16 over 12 equals 4/3. Okay, this over this. And then we want to do 8 over 6. Okay, QR over RM is equal to 4/3. So since NP over PM is equal to QR over RM, NQ is parallel to PR by the converse of the triangle proportionality theorem. I'm not going to write all that down, but you want to listen to this so that you know what the answer actually is going to come out to. Okay, so if you're just watching this, I sure hope that you are at least reading the subtitles or reading the closed captions. Okay, let's come down here to 29. Name the inscribed angle shown in the circle below. Okay, inscribed angle. Let me come back to this. 29. It's kind of an odd question. It's like a little bit like there's not enough information here. Name the inscribed angle shown in the circle below. Well, they're saying that it's angle EFG. There's actually a couple of inscribed angles, but this is an inscribed angle here. Angle, HGF is also an inscribed angle. So you've got this angle here is inscribed, as well as this angle right here is inscribed.
Morning, Mr. Wilcox.
Morning.
Have a great day.
Yeah, you too. Okay, but angle EFG is the one that they're actually asking for. Okay, and I think I understand. The reason that this red one is not inscribed is because it doesn't go out to another endpoint. It just goes to the center. So the actually only inscribed angle here that has endpoints, okay, on the circle, okay, is angle EFG. That's why they're going with that on 29. Okay, let's look at question 30. Classify the three-dimensional solid shown below. This would be a rectangular prism. Has a rectangular base, has another rectangular shape parallel to it up top. There's really nothing else to add there. It's a rectangular prism. (31). Okay. This is lesson 55, triangle mid-segment theorem. Triangle ABC has vertices A at 2, 6, B at 3, 2, C at -2, 1, as shown below. DE is a mid-segment of triangle ABC. Find the coordinates of DE. Okay, because it's a mid-segment, D is a midpoint of AB, and E is a midpoint of CB. So you're actually just showing the midpoint formula twice. So 2 plus 3 divided by 2, and 6 plus 2 divided by 2. 2 plus 3 divided by 2. 2 plus 3 is 5. 5 divided by 2 is 5 halves. So I could write it up that way. 6 plus 2 is 8. 8 divided by 2 is 4. Okay, you can see how well that's going to work out. We should get, this is the same as 2.5, 4. Okay, and then let's do this other one over here. You're looking for the midpoint between C and B. So we've got -2 plus 3 divided by 2, and 1 plus 2 divided by 2. -2 plus 3 is 1. 1 divided by 2 is 1/2. 1 plus 2 is 3. 3 divided by 2 is 1.5. Okay, so let's look at our answer key here on 31. 31, D is 2.5, 4, and E is 1/2, and 1.5. So we've got D, and we have E. Okay, and that's how we're going to show where those are. Okay. All right, 32, we're getting close here to the end, which is great. Get this out to you as soon as possible. 32 is another 30, 60, 90. They're showing that my short side is 20. Remember that it is a ratio of x, 2x, x radical 3. So I know that x, x here is going to be 20 radical 3. And now I'm going to take x times 2, and that's going to give me 40. Okay? So my answers are 2 radical 3 and 40. Looking at question 32, 20 radical 3. No, sorry, not 2 radical 3, but 20 radical 3, and y equals 40. Okay, just knowing our ratios helps us out a lot there. If you don't remember them, go back and look at lesson 56. Okay, and spend some time practicing there. I believe you should even have a video over lesson 56. 33, last couple questions. Find the perimeter of rectangle ABCD with coordinates 2, 0, 1, -4, -2, 1, and -3, -3. Give your answer in simplified radical form. Here you're going to use coordinate paper to figure this out. I'm just going to give you your answer here, and if you work this out and you struggle with it, I can tell you that your answer is 4 radical 17. It comes from lesson 57, finding perimeter and area with coordinates. Notice that they do tell you it is a rectangle. You can do this without showing any kind of picture. If you just find the length from A to B, the length from B to C, the length from C to D, and the length from A to D. If you just find all 4 of those lengths and add them up, you'll get your perimeter there. Okay. If I've got time after 34, I might go back and actually do that with you. 34 here says in the figure below, AB and AD are tangent to circle C. Notice that they both come back here. Okay, which means I know that AD is 15. We know that this is a right angle because these are tangent lines. Tangent lines are perpendicular to the radius. We know we've got a straight line coming back here. We know that this is 10 there because all my radiuses are 10. What type of quadrilateral is ABCD? A lot of people struggle with this one, but it is a kite. And they ask me, what is the perimeter? So we're taking 10 plus 10, which is 20. 15 and 15 and 30, so we get 50 inches, and we get a kite. Okay, so I think I have enough time to actually go back and do 33. So let's take a look at that from a distance formula standpoint. A to B. All right, so we've got 2 minus 1 squared plus 0 minus -4 squared. Okay, so here, we got 2 minus 1, that's 1 squared, plus 0 plus 4 squared, that's just going to be 4 squared, so should be 4 squared, sorry. Okay, 1 squared is 1, 4 squared is 16, so I get square root of 17. So I know I'm going to just put this off over here. I got square root of 17 for one length. Okay, we'll leave that because I want my answer in simplified radical form. Let's go B to C. Okay, so we got 1 minus -2 squared plus -4 plus 1 squared. Okay, well that's actually 1 plus 2, which is 3. So I got 3 squared plus I got -4 plus 1, which is -3 squared. All right. Well, I've got 9 plus 9, so I have square root of 18. If I've got that right, square root of 18. I don't know. Let's see if that square root of 18. Let's see if that will reduce. Let's see. That's 2 and 9. That's 3 and 3. So it's actually 3 radical 2. I don't know if I've got that right or not. 1 minus negative 2, negative 4 plus 1. 1 plus 2 is 3. Negative 4 plus 1 is negative 3. Squaring both of those, I've got 9 and 9, which is 18. All right, well, we'll come back to that if I got it wrong. Okay, let's do C to D. Let's see, we got negative 2 minus negative 3 squared plus 1 minus negative 3 squared. Okay, so I've got negative 2 plus 3 squared, which is 1 squared, plus, and then I've got 1 plus 3 squared, which is 4 squared. I'm going to get that same radical 17 again. Okay, because I've got 1 plus 16. Okay, now finally, A to D. Let's see, let's do 2 minus negative 3 squared plus, let's see, what else do we have here? We've got 0 minus negative 3 squared. All right, well, 2 plus 3 squared is 5 squared plus 3 squared. Okay, so it looks like I have 25 plus 9. So I've got square root of 34. Okay. Let's see. 34 divided by 2. 17. Okay. So I can't reduce that any further. Okay, find a perimeter, give your answer in simplified radical form. All right, I think I see at least one mistake I made, which is back here from B to C, that this is 1 minus negative 2 squared, which is 3 squared, but negative 4 minus 1 squared is negative 5 squared. Okay, which is giving me that square root of 34 again. Okay, so we have this right here. We've got square root of 17 plus square root of 34 plus square root of 17 plus square root of 34. So there is a problem with this question, and the problem with this question is that it doesn't go in order A, B, C, D around. It actually goes from A to B, B to D, D to C, which in the end gives me radical 17s all their way around. So my final answer is 4 radical 17 for my perimeter. So you actually won't see that unless you graph it. So I'm telling you on this one, you need to graph it and check those distances. Otherwise, you won't get the right answer on that. So anyway, that should complete all of that. That question number 33 was from lesson 57.